Hello and welcome. Today we will be learning about reciprocal functions. The standard form of a reciprocal function is f of x equals c over ax. Let's examine a graph of a reciprocal function. Here we have f of x equals 1 over x. As we can see, the graph has an asymptote of 0, meaning it will infinitely approach 0, but never reach it. This is because x is the denominator, and a denominator cannot equal 0. Now let's look at another graph. Here we have f of x equals 1 over x plus 1. This graph has shifted left 1. This is because the asymptote is now negative 1. If x were to equal negative 1, the denominator would equal 0. And because the denominator cannot equal 0, x cannot equal negative 1. Let's move on to the next graph. Here we have f of x equals 1 over x minus 1. Here we can now see the graph has shifted 1 to the right, now with the asymptote of 1. Here we can see if x were to equal 1, the denominator would equal 0. And because the denominator cannot equal 0, x cannot equal 1. Let's try something with a slightly more complex denominator. Here we have f of x equals 1 over 3x minus 2. So what can x not equal? To find that out, let's set the denominator equal to 0. 3x minus 2 cannot equal 0. We know that much because it is the denominator. So if we solve for x, we have 3x cannot equal 2, and x cannot equal 2/3. So our asymptote is 2/3. Now try one for yourself. Try finding the asymptote for the graph f of x equals 1 over 7x minus 10. Let's move on to a new graph. Here we have f of x equals negative 1 over x. We can see this graph looks a lot like 1 over x, except everything's flipped by the y-axis, meaning what was on the right is now on the left, and what was on the left is now on the right. Here we have f of x equals 4 over x. We can see when we change the numerator to a larger number that the graph moves further away from 0 and the curve becomes wider. And finally, let's examine f of x equals 1 over 4x. We can see that by multiplying the x by 4, we move the graph closer to the center and give it a sharper curve. Thank you for watching our video. If you have any questions, please ask now.